Hello, my name is Paul Bevan from Siemens Digital Industries Software. And in these demonstrations, you'll see me taking a look at some of the new capabilities for advanced shape design and validation in the June 2023 release of NX. In the graphics window, you can see that I have two conceptual sketches for an electric shower cover. And I've imported these as raster images, and I've been able to use these directly to construct the base shape of the shower cover. I'm going to temporarily hide the side profile of the shower cover and just concentrate on the front. And it's this front profile that I've used to develop sketches and curves that will allow me to cut a scallop out of the shower cover itself. So I'm going to start by hiding the front raster image. I don't need that anymore. And I'm going to bring back a simple 4-point surface that I'm going to use to help me develop the scallop. Aesthetics are a key consideration when developing this scallop, or as some may call it, a depression in the shower cover. I need to make sure that the transition between the scallop and the original surface is as smooth as possible. I don't want to see any hard edges when light reflects off it. And we have the perfect tool inside of NX to achieve this, the match edge command. So let's take a look at how it works. The first step in the process is to select the edge that I want to match, which is this top edge of the simple 4-point surface. And then I select the reference geometry. That's the geometry I want to match the edge to, which is the projected curve on the top surface. Now you'll notice an alert has appeared in the bottom right-hand corner of the graphics window, which is telling me that the parameterization of the surface is insufficient to meet my tangent continuity demands. This is simple to rectify. All I need to do is to up the degree of the surface, and you immediately see the effect that has, with the edge of my 4-point surface now matching the projected curve on the top face of the shower cover. Now the current edge continuity is set to tangent, which is fine, but it may not give me the really smooth transition that I want. So I'm going to change the continuity to curvature and then flow to see what effect that has. And you can see the surface dynamically updating. I can then use some of the powerful analysis tools to perform some real-time validation on the surfaces. Here I'm using reflection analysis, which is similar to having a strip light above the part. And you can see where the flow lines from both surfaces meet and how they continue into each other. You can also see that when I change the continuity type from curvature to tangent, that the reflection lines update dynamically. Notice that the tangent condition is a lot sharper than the smoother flow that I get with the curvature continuity. And it's this one that I'm going to use. Now that I have the surface continuity I need, I can continue with the design of the scallop. And the first thing I'm going to do is to define the lower boundary of the scallop. And to do this, I'm going to use trim sheet. I pick the sheet body, I pick a curve that's going to define the boundary, and then a vector to project that curve onto the surface. Notice I get a preview, and when I complete the command, I've now trimmed that surface back to that boundary. So now I need to create the outer boundary of the scallop. And to do this, I'm going to show an existing projected curve that was created earlier on in the design process and generate a surface between that and the inner profile. I simply select the projected curve and then the boundary of the surface I just trimmed, and a preview of the surface appears. I can now define further continuity. In this case, I'm going to specify tangency or maybe even curvature. And again, you notice the surface dynamically updating. And now I'm going to apply continuity to the first section, but I'm going to do this a little differently. With the last section, I picked the edge of the trim surface, and it took the parameterization from that surface to define the continuity. However, with the curve on the surface, I need to give it a bit of a helping hand. So I'm going to tell it which surface I need the continuity to match. So I select the top face, the surface preview reappears. I can change the continuity from tangent to curvature. Again, you see the surface dynamically update. And if I'm happy with it, which I am, I can now complete the command. So I now have three bodies visible. The main shower body itself, which is a solid body, and two surface bodies that represent the scallop. So the next thing I need to do is to amalgamate the two surfaces. And to do that, I'm going to use the sew command. I simply select both bodies and apply the command. And this basically unites the two surfaces together. The final step of the process is to add the scallop into the shower body itself. And to do this, I'm going to use another powerful command in NX called patch. After activating the patch command, I simply select the main shower body as the target and the sewn sheet bodies as the tool, and on completing the command, those surfaces have been incorporated into the shower body, creating the scallop I wanted. So I'm going to hide some of the extra geometry I don't need and change the display of the shower cover from translucent to opaque. And when we do this, we get to see exactly what we've done with the scallop in the shower cover. And when I remove the face edges, you can see how smooth the transition is between the scallop and the shower cover. We can continue to analyze the surface further, again using the reflection lines, and again this gives us a really good view of how good our transition is between that scallop and the main surface. As this is a plastic cover, it needs to have wall thickness, so we'll simply shell out the solid body. You can see how the scallop is now incorporated into the shell. As I continue to rotate the model around, again you notice how smooth that transition is between the scallop and the main surface. Finally, let's take a look at the shower cover with three different glossy plastic materials. We'll start off with a more traditional white before we move on to a blue color, and then finally a green. And again, you can see visually how smooth that transition is between the scallop and the rest of the shower cover. So let's just recap what you've seen. I needed to add a scallop into my shower cover. I used the powerful match edge command inside of NX to create a smooth continuity between a simple surface and the main shower cover top surface. I was able to validate the smoothness using some of the powerful analysis tools inside of NX, such as reflection lines. And then I continued to define the scallop using a combination of trim surfaces and studio surface, again, which I was able to control the continuity between it and the main body of the shower cover. We were able to add the scallop into the shower body using the patch command, and again reevaluate to ensure that we had the continuity that we needed. Finally, we took a look at the shower cover in various colors based on a glossy plastic material. I'd like to thank you for your time and attention.